So we haven't practiced this.
No.
We met at the bar on Sunday,
Oh, yeah.
and they didn't have Wi-Fi at the bar, so we didn't get anything done.
We got lots of things done. They had nothing to do with this.
We should thank our sponsors.
We should thank our sponsors. Thanks, Elastic. Thanks, RocDev. Thanks, NLX. And thanks all for coming. You are true Rochesterians.
Yes.
You have just
Look
said,
at
whatever,
that tree.
snow, I'll be there.
White Elk.
Pizza?
That tree looks
Sure.
particularly gusty.
We're going to talk about Elastic. This is actually Jeremy's talk, and I stole half of it.
Well, that came up because Max, George said, hey, when are you going to present on Elastic? And I said, how about like November? And Max said, well, what are you presenting on? Are you presenting on search or are you presenting on analytics? And I said, well, you can run a query, that's not a big deal. And Max was like, actually, there's a science behind it. And I said, oh, maybe you should educate us, all of us. So Max said, that sounds great. I'll help you with your presentation. And Max is like super duper expert at search relevance and search tech for open source.
Open source connections, which is a mouthful. OSC, O19S. Because like K8s for Kubernetes, O19S. Just go there. Open source connections if you want to type out the whole thing. Yeah.
So yeah, Max said a whole bunch of words that I tried to follow. And he's a smart guy. So I'm going to turn it over to Max for a little while.
And then I'm going to introduce Jeremy when it's his turn and talk amazing things about Jeremy.
Okay.
So, thanks for the intro. I work in search relevance. I work for O19S, Open Source Connections, OSC. We also run a conference on search relevance, which gets about 120 people. We run it twice a year, once in Charlottesville, Virginia, and then once in the EU. We alternate, so twice a year. Alternate locations. I'm a managing consultant, and I talk to big clients about their search problems. Search problems is not SEO. It's not like, oh, my stuff isn't showing up on Google. It's, I've got a search bar on my product or application, and I can't find what I'm looking for. And that's what we mean when we talk about search relevance. So I'm going to talk about the search part of Elasticsearch. So what's search? Search engine technology, data engineering, human language, relevance psychology. I'm not going to go super deep into these topics. I think I have 45 minutes-ish. Whatever, we'll fill it out, see how much time we want to spend. I can spend, well, I'm a consultant, so I can spend 20 years talking without stopping to breathe even. But I spend a lot of time talking about this stuff. And I give training specifically around these things, like our training course is a 2-day course. And I'm going to condense that down to like 45 minutes for you all. So the engine technology is what we're going to talk about tonight, but I want to just call out the other 3 boxes here. So data engineering, you can't search for things unless you have content to search for, and unless you know what your customers are searching for. So that's gathering all of your documents, processing them, a lot of ETL, a lot of enrichment, that type of stuff, and then pulling in queries from your logs and understanding what people are searching for, and then using that to improve signals and things around there. Human language. So people type stuff in a search bar, and it's human language. And computers are terrible at understanding human language. It does not exist. It's ones and zeros, numbers, good stuff like that. So that's a big gap. We're not really going to talk about that tonight. Relevance psychology. So there's this deep field of study of subjectivity and bias, and I'm going to search for something, and I think it should be this. Some other person's going to search for the same words, and they think it should be that. So there's a lot of that. We're not going to get into that tonight, but there's a whole field there. There's probably like 20 other fields that I've left off here. There's a lot of new things that are happening in search, which is pretty exciting, but we're just going to do the basics tonight. So basic of Elasticsearch, just how to create an index, how to put documents into the index, what's the difference between an index in Elastic versus like a database table. We're going to talk about the basics of relevance engineering. So when you get documents back, why are you getting them back? What does it mean in the world of Elastic? And actually, this is about Lucene, because Elastic is a pretty fancy piece of software, but it wraps an open source library called Lucene, which is a Java application. And that runs the full text indexing core of Elastic. We're going to head over to the dev console. All the stuff that I'm going to show is open data. You can use it. I'm also going to use a tool called Splainer, which is open source when we get into the relevance engineering part. And I'll show you, if you're interested, talk to me after the thing, and I'll show you how to get all that stuff. So, stop. Come on. Stupid touch bar. Okay, so that's that, and now we're going to head over to, here we are. And I think this should work. Let me see, how does that look? Is that way too small? Should I blow it up a little bit? We're good? Okay. Okay, so I mentioned, actually I'm going to do this. Let's just get rid of these things. Oh yeah, I can't do that. Okay, so I can't get rid of all that stuff up there. Whatever. So the thing about Elasticsearch is that it has a really nice RESTful API that you can use. There's a server running in your house?
Literally my basement.
Literally in Jeremy's basement. We're talking to that. You'll connect, if you want to follow along later and bust out your laptop when Jeremy's doing his thing, you can connect to his server and play around with some visualization analytics stuff. For now, this is just, I'm in Kibana, but Kibana talks to Elastic. So Kibana needs Elasticsearch to run. So I'm going to just use the dev console in Kibana, and I'm just doing pure Elasticsearch stuff. I'm not doing any Kibana things, but they have a nice dev console here that I'm going to use. It supports things like comments and weird stuff, and this is the format. So you have an HTTP call. So I'm doing a put /RocDev. So I'm going to create the RocDev index, and this is my schema, and you can actually see the whole thing here. Well, not anymore. Okay, you can see the whole thing here. So we've got core parts of a schema. But before we talk about those pieces, we have to think about what we're actually doing. We're indexing text. We're going to put text into Elasticsearch, and we want to be able to search for it, right? So just like you'd index stuff in a table, in a database, so you can get it back out, first we have to set up what a table looks like, right? So I'm using this analogy, but it's not a really good analogy because database tables and indexes are very different. I'm going to talk about that a little bit. So we've got some stuff we've got to do. So the important thing here is I've got all these things, and I've got this one thing down here, and I have this thing called notes. I'm going to create an index that is going to store text for documents that has one field, and that field is called notes. That's it. This is about as simple as I can get. It's a type of text, and I have an analyzer. So when text comes in through that field, I specify, I'll jump ahead quickly so you can see what I'm going to pass in for a document. So this is what I'm going to send in for a document, right? So the cat in the hat, the cat sat on the mat, right? So this is some HTML. So going back up here, I've got my notes, and then I analyze the text for that field. So when I specify notes field, I got text. The text comes in and it looks at this analyzer, and the analyzer says, okay, this is a custom analyzer. I'm going to go through these things in order. So first thing I'm going to do is I'm going to strip the characters out, the HTML characters out. So I had p tags in that document that you saw. I'm going to get rid of those. I'm going to tokenize. Tokenization means splitting up into tokens. So this is typically on white space punctuation. So now we've got like the cat in the hat is like, now we have the cat in the hat separated by, so it puts it into a list, array, whatever. The token stream is actually the technical term in Lucene. And then I'm going to put each token through a process. So I'm going to lowercase the token. I'm going to put it through English stemming. Stemming is when you chop off stuff for normalization because you want stuff to match. So I've got like the word cat. If I had the word cats, plural, I'd want to get rid of the S. So if I search for cat, I'm also going to get cats, and vice versa. So I have to set up this stemmer here. So I've just got a basic English stemmer. I'm calling it English stemmer. It's a type of stemmer, and it's English. And I do that, and it's filtered. And then I go down. Oh, I have to create this thing first. So now I'm going to create this. Yay, it worked. I get a response. Wonderful. And I'm going to add the document. So I got this document here. I get some information back. Document 2. I'll create this. Document 3. Create this. Document 4. Create this. Okay, so now I'm actually going to go over to the whiteboard for a second because this is important. And this is really the difference that you have to really understand to grok search in Elastic. So we're going to talk about an inverted index. Oh, sorry, I totally messed up your videography. Cool. Oh, we're going into...
We're doing it live.
We're doing vlog style.
All right, so I've got, let's just say, cat in the, if I can spell, hat. So this is a document with ID number 1. And then let's say I have another document with ID number 100. Cat ate the mat. Which, hope your cat doesn't eat the mat. Okay, so what happens is when it's processing this, it's creating an inverted index. An inverted index is if you flip to the back of any textbook, you're going to see a list of terms and what page they're on, right? That's the data structure that Lucene builds. So now we've got cat is in document 1, in is in document 1, the is in document 1, hat is in document 1. Now we get to this document, we've got cat is in document 100. We've already got cat in our dictionary, so I'm going to say, well, this is in 100. Now I've got a new term, 8. That's in 100. I've got the, that's in 100. And I've got a new term, mat. That's in 100. So now you can see that this is this data structure that is stored. It's way more complex than this. There's a lot of metadata that you can put in here. But this is a term, and it looks up things by terms and what documents they're in. So when I go to the search engine and I search for cat, it's going to be really quick because then it's going to say, oh, cat is in the documents 100, 1 and 100. Here you go. You know, like really, really quick. And that's the point of the inverted index, to have that very, very fast lookup. And the processing of this is pretty quick as well, because it's order n or whatever to do this, and then nlog n for the search and the addition in the dictionary, depending on if it's a new term or not. And this is a really, really fast operation to write and read from this index. The thing that Elasticsearch adds on top of this is it adds a nice query language, and it adds the sharding and scaling out of Lucene, because Lucene is just a library. It doesn't know what another server is or anything. It's just like, I got my disk, I'm happy. So it splits indices up into huge things across multiple dozens, hundreds of servers. Okay, that's an inverted index. So, quick time check. Oh, I'm doing all right. So now we've got these. So if I search for dogs, I'm going to get a document back. I'm going to get a couple documents back. So I did this search, and let's talk about this for a second. So I've got, this is the query DSL. My cursor's in the way. So I get /RocDev /_search. This is the search operation for the index. And there's a RESTful call. And I say, well, here's my query. I'm going to do a match query, which is the most basic type of query you can do. I just want to match the keyword in the field notes, and here's the keyword I'm passing in. So I passed in dogs with a capital D. And you can see the documents that I got back. I got dogs with a lowercase d because I lowercased it when I was indexing. And I'm also lowercasing it when I'm searching. And I get dog, so that does the stemming. So I search for dogs, I get dog, right? So I've got these two things. The nice thing about Kibana is that, so there's a whole lot of query, there's a whole query DSL. This is a whole language, querying. Kibana lets you do nice things like auto-completion of the query, which is really helpful. So if you're getting started with Elastic and you want to learn how to write queries, first of all, I go to the API docs all the time because I don't have the whole query language memorized. And there's a whole rich set of stuff that we'll get into a little bit. But this is a multi-match query. So a multi-match query lets me query different fields. So I'm going to query dogs again. I only have one field in this, and this is notes. But you saw the nice auto-completion that this did. I selected multi-match, it gave me the stuff. That's gold right there, because typing this stuff out, it's a lot more verbose and complex than, say, SQL. I think SQL is complex enough, but Elastic has a lot more stuff. And I've seen Elastic queries that are tens of thousands of lines long, no doubt, of JSON. And they're really, really hard. So Elastic also supports query templates where you specify a template and you say, well, I just got my query that I want to pass in. I'm not going to pass in the whole query every time. I'm just going to pass in my text and we'll use the template. Okay, so let's look at some other stuff. So some interesting statistics about this document. There's an interesting thing. So deprecation, Elastic really is on top of keeping their software clean. They tend to deprecate and change a lot of stuff. Upgrading can be a bit of a hassle sometimes, so that's something to keep in mind. If you go on with a version, you build around that version, pay attention to the deprecation warnings of the things that you're using, because they are serious about it, they will remove it. Upgrading from 6.4 to 7.5 for this demo, I ran into an upgrade problem, and it was a very simple demo. This is how you query the term vectors. Those are the term vectors, those things that you saw over there for the index. And it just gives you some nice stats. I'm not going to go through all this. I don't want to waste a lot of time. I'm just going to delete my index. It's gone. There you go. Pretty simple. Okay. That was a fairly useless example. Those are just some notes. You can make your own to-do list or whatever and search for it, which you will never do. Something more interesting is when I give training, we use an open movie data set called the movie database, not internet movie database, the movie database, TMDB. You can go to themoviedb.org or .com something, and you can just download all this data. It's about, we have about 27,000 documents in here, which is not a large number. But it has a lot of fields, and you can do some really interesting stuff with it in a demo sense. I've already indexed this. I've already created the schema. Where's my schema? Where is... that's an article I'm writing. That's not it. Oh yeah, here we go. Schema. So this is my movie schema. It's pretty big, so there's a lot of stuff. I just wanted to show that because schemas can be very complex. So I'm going to search Will Smith. Will Smith is an actor. I'm going to search the title, the cast, and the overview fields. I search for Will Smith, and the first document that I get back is Mr. Smith Goes to Washington, which is, of course, a very popular Will Smith movie. It is not a popular Will Smith movie. This is where we get into the world of relevance engineering. So this is the problem I was talking about before. This movie is not a relevant document for my query Will Smith. Not even close. I know how to fix this problem because I've been doing this for a long time, so now I just search for this field instead, and now I get The Pursuit of Happiness, which of course is a Will Smith movie. I don't know if it's the best Will Smith movie that should come to the top result, but at least it's a Will Smith movie. And now I have this here. So what is this thing that I just did? So I have this thing cast, and now I'm searching instead of cast, this field, text people no TF front. So that's a mouthful in terms of saying it and what it actually is. So let's look at the mapping for text people no TF front. This is taken from the schema in chunks. I just dropped them in here for readability. We've got type text, and we've got an analyzer as names front. If you remember, the notes had an analyzer too. And we've got a similarity, and I'm going to talk about the similarity in a minute. Here's the analyzer. So names front, type custom, tokenizer, standard, filter, lowercase, English possessive stem. English possessive stem just removes, like, if I'm a person, apostrophe S from the end of a word or a name. And I've got my length limit is a filter. So now I have a filter, custom filter that I've set up, which is type limit, and max token count is 10. So that means I have a whole cast of people who appear in a movie. I set up this filter because I only want the first 10 tokens of the cast field. Here is the cast field for this movie. So you can see all of the people in there. Will Smith, his kid, Thandie Newton, Brian Howe, James. So 10 tokens, remember this is in tokens, is about 5 people. So I'm going to just take the first 5 people, and I'm going to forget everybody else that comes after the first 10 tokens. And that's what's indexed in this field, text people no TF front. It's just chopping it off, throwing everything else away. Now, so I've got that, and now I've got a similarity function. The similarity is what scores the document. So when you get results back from Elasticsearch, it scores each document according to relevance, or really the technical term is similarity, because it just says what is most similar mathematically to the query that I gave it. So this is what I've got here. So we've got this set up, no TF similarity, type BM25. BM25 is, who's heard of TF-IDF? Okay, so term frequency, inverse document frequency. The number of documents that a word appears in. So over there we've got cat appeared in documents 1 and 100. It has a document frequency of 2. It appears in 2 documents. The word hat appears in 1 document. It's got a document frequency of 1. Inverse document frequency is the reciprocal over that. So 1 divided by. So that measures the rareness of the term. If a word is only in 1% of the documents versus another word that's in 10% of the documents, this word is more rare. So it kind of makes that word more important for the query. Stop words are things that appear in all the documents, like the word the is going to be in 99% of documents, maybe 100%, depending on the corpus. So that's the inverse document frequency. Term frequency is the number of times the term appears in the document that you're analyzing. So for the first document up there, we've got cat in the hat. So if I search for cat, I've got a TF of 1, term frequency of 1. Cat appears in that document once. And then we multiply that by the inverse document frequency of 2. That gives us 50%, 0.5. BM25 is a mathematical formula that does that plus other stuff. It takes into account the length of the field that you're looking at. So shorter fields, typically a term appearing in a shorter field has more aboutness of that field. So if you've got a paragraph of text and you've got a term appearing once in that, there's a whole bunch of other stuff coming in there. If I've got 3 words and that term appears in those 3 words, well, that 3 words is a lot of aboutness there, right? So we've got aboutness and rareness are the 2 important signals of relevance for a field and a query. I've got a calculator here. I'm not going to go into this. This is probably a bit much. But we've got some more advanced stuff we can do with the query DSL. So I'm going to do this multi-match field. Ignore this cross fields thing. It just searches for across the fields in a different way with a different formula tweak. So I'm going to do that search, and I'm also going to do this, where if Will Smith matches 100%, so we've got now a Boolean clause, kind of, where I'm going to add a score to this if Will Smith appears 100% of the time. So sometimes you could have the word Will in there, you could have Smith. If I type a query that's 5 words long, I'm going to have like a certain percentage of those terms are going to show up in different documents depending on what I'm going to find. So if Will Smith is in there 100% of the query, I'm going to take the release date. I'm going to have a decay function that says, well, older movies are less important. I want recent movies with Will Smith. So when I run this, now I've got Collateral Beauty. So this data set is a little bit out of date, maybe like a year or two, but this is more recent than The Pursuit of Happiness. I'm not a huge Will Smith fan, but I know I like movies. So I know that movie came out after that one. So now we've got a reordering, a boosting of more recent movies higher. And this is just a Gaussian decay over 900 days. A Gaussian decay is kind of like that. A linear decay would just be like that. So it kind of tapers off a little bit and then doesn't drop below 0. Right. So we have an open source tool that we use a lot called Splainer, because this scoring thing is really tricky. It's really hard. There's a lot of stuff going on. So I've got this query here. It's the same query. And I just wanted to show you, but this is a more updated database. Is it? You run query, and of course. Why are you not working now?
It's probably an older version.
I'm not pointing at I'm pointing at a different. Oh, cores? Really? Hold on. Okay. Here we go. So my local machine is running this now. Here is the score. So I've got a lot of stuff going on in this query. Let me move this over here so you can see this again. Get rid of that. And this isn't a great editor, but you can drop stuff in and you can play around with it. So I got now this Gaussian function, which is going to be this is how Elastic expressed that. You can pass a debug setting into Elastic to get all this scoring stuff back, and we just wrap this in a little UI. So if I go to detailed, this is what's going on. So I'm going to go to the full explain. And this is the BM25 score, right? I mentioned that algorithm, BM25, before. My query is Will Smith. I've got that release date decay function. So I've got the sum of, and this is going to go into the TF-IDF stuff, the maximum of the sum of this. So the weight of Will in 1880 per field similarity result of this. This is relevance engineering, people. This is the good stuff. The score, so this is the term frequency. This is document ID 1880. With the IDF, inverse document frequency, is 493. So Will appears in the corpus 493 times out of 27,000 documents. So that's the IDF. Now we've got the TF is 1. So I've got the TF norm here, but this was calculated as 1. And this is the term frequency taking into account the length of the field. So that is the score for that document with TF-IDF. And then we've got this other thing, the function, which goes into here. Some of yada yada, and is going to be a lot of this. Oh no, this is Smith. We had Will, and now we have Smith. Where's the? Hold on. Function of release. That's what I wanted. Here we go, down here. Okay, so now this is the Gaussian decay of the release date. So that's how we get this. So there's one of these for every single document. So this document for that query had a score of 251. This document, which is this even a Will Smith movie? I have no idea. 237. Suicide Squad, 197. Pop Star, is that a Will Smith? I don't know. 174. So we spend a lot of time tweaking a lot of stuff to make the right documents come to the top of the result set when people search for things. And there's a lot of stuff that we do to make sure that happens. We label a lot of data. So we say, well, how do you even know what's relevant? We have to label. We have to say, well, for this query, I want to see these documents. And then you run a test, and you get a metric to say, well, I have an accuracy of X. I want to get 10% above X to be satisfied with that metric for that query. We do a lot of this stuff. We've got tools and techniques and all that stuff. But that's for another time. That is Elasticsearch, the search part. Thanks, everybody. And now my esteemed colleague, Jeremy.
Okay.
You have to introduce yourself.
That's fair. I'm an architect with Thomson Reuters. I work remotely. And I have to admit, you lost me.
That was like 2 days and
dense.
45 minutes.
Yeah, it was dense. But I mean, it's good. Like, it's not voodoo magic, and you can see that it's not voodoo magic. But it was pretty intense. Yeah.
I didn't even get into facets, which was going to set you up for everything, because the way that things are counted is how the analytics works in Kibana.
Right.
So those things over there are really important for what he's going to talk about.
Yes, and I'll touch on that a little bit.
You can use this, or you can use your own. Or
I don't have a
slides.
PowerPoint on.
Oh, okay.
One quick question: is Kibana part of what you get, or is that a separate tool?
Yeah. So. Yes. So Elastic as a company has a bunch of different tools. So Elasticsearch is the engine. It's sort of a bunch of web services that sit on top of Lucene. Kibana is generally regarded as the UI.
Oh, okay.
But you can have an Elastic cluster and then have a single instance of Kibana sitting on some other machine that just points at that cluster. So it doesn't matter whether you're accessing Elasticsearch itself through Kibana, through some app that you write, through Postman, through whatever REST API tool you want to use. And I can show you some of, when we get into analytics, I can show you how Kibana actually puts together some of its queries. And so it's kind of neat. Yeah, so what's analytics? A lot of it has to do engine technology. A lot of it has to do with the inverted index and how it stores the data. Data engineering, always data quality issues. When you do analytics or you pull things into any BI tool, 20% of the work is the tool you're working with, and the other 80% is actually figuring out who to talk to get the right data in the right formats with the right context so that you can actually make sense out of it. Discovery UI, that's what Kibana is. As you'll see when we go through this, we can kind of just poke at charts and numbers, and things sort of start to fall out into our lap if we build the visualizations the right way. Machine learning, the enterprise version of Elastic. Here's my shill for the company. The enterprise version of Elastic will take a look at any given metrics, and then if they fall out of bounds over a certain period of time, you can say, oh, send me an email, or do this, or do that. And that's really one of the enterprise offerings. That's how Elastic as a company makes its, stay sustainable. So that goes into it too. We're going to start off the server that I was running that Max was talking about. I ingested data from the New York City bike rental program, and it's hosted here, but the information about it is up here. So if you guys want to go poke around with the raw data, it's just in CSV format. Here's where the source is. I put the code that I use to ingest. Basically, it slurps it in, parses the CSV, dumps it back out to bulk requests that go into Elastic. You just point it at an Elastic endpoint, plows it in there. It takes about an hour. Hopefully I can do this walkthrough as a markdown document and put it up on GitHub at some point, but with Christmas it's always kind of interesting, especially with little kids. So let me get you on here. Now if you've got your laptop and you feel like following along, now's a good time to do it. I've made sure that this RocDev.mushroomboulevard.com is where I have Kibana hosted for anybody who feels like going into it.
What's Mushroom Boulevard?
That's my domain. We were driving down the Jefferson Market, yeah. And my wife said, she looked at the street sign. She said, that street sign's awesome. Can we stop and steal it? And I said, how about we register the domain instead? So now we have email addresses at mushroomboulevard.com.
Also, it's nothing to do with the street. It's not that you live over that street.
No. She just really liked the name, so we rather than steal the street sign, I registered the domain, and that was like in 2001 or something. And back when G Suite was free, and I signed up for the G Suite business for all of that. Let's see. Oh, I don't have. I disabled the DevTools. Anyway, with this city bike demo that we're gonna run through, Max had 27,000 records in his data set, and the city bike one is about 85 million. And that's running on 4 cores, 16 gigs of RAM, maybe about 20 or 30 gig footprint. And this is what Elastic, their main use case has become real-time analytics. It's so fast, especially with low cardinality data, high repeating values, high numbers of repeating values. It is so fast that a lot of what they talk about when you go to their conferences is log parsing and that log text indexing and ingesting petabytes of data, which turns into hundreds of billions of records every day for some of these huge companies. And you spin this thing up and you can just throw it on a couple hundred servers. It'll just auto balance and handle all of the magic for you. And you just go in there and you're like, okay, well, let me see how often error popped up, and just it starts filling everything up. So you get pretty specific in your search terms. And the reason this works, I'm not text parsing like this, but I have keyword value. So what I'll have, instead of having these documents that are really wide, multiple, sometimes hundreds of or thousands of tokens, my data sets will be really long this way and narrow. So what ends up happening is I might have, a couple hundred values long in the inverted index, but it goes on for billions and billions of document IDs. And that's still fast.
When you get inverted index, is that database driven, or is that?
So that's Lucene. So Lucene again, is a Java application library. You can use it standalone, but typically it's used inside of a bigger Java application. And it takes text, and it has its own language. And you give it text, and it parses the text through various. It has APIs that you can use, and it creates this data structure, and then it persists the data structure to disk. And it has a very efficient paging mechanism, the way that it uses the disk and how it brings things into memory to query, and how it writes into memory and drops it into disk. So Lucene is incredibly good at that. It does that extremely well. So that's really the workhorse behind both the search side and the what we call facets, but this data structure here. So it is a database because you are storing data, but it doesn't use a relational database.
No, it's not, okay.
It is its
Yeah.
own.
So it's kind of like Elasticsearch is, if you're familiar with CAP theorem, Elasticsearch falls on the AP side. So you'll have the CA side for something like SQL Server, CP for MongoDB. Elasticsearch, you're not going to track financial anything in, because you might send a record to the database and it won't be available for 5 to 10 seconds sometimes, because it's indexing, it's processing, it's generating that structure. But looking back on things, it's really fast to pull things out that have been done previously. So it's really popular to put something like Kafka or Amazon Kinesis or some other streaming consistent data source in front of Elastic, and then have a pipeline to Elastic to do all the aggregations and lookups later. Yeah, where was I going?
Talk about your table being narrow and wide here.
Yeah. So with a search application, and you're searching maybe text, you can search entire books, and that'll be one really wide document. You can also have really narrow documents and very, very many of them, and that works pretty much equally well because of the way the index is structured. So let's go ahead and get into this. I'm going to sit down for this because it'll be easier to stay on top of my computer. First thing I'm going to do is pop over to the Discover tab. And a lot of what you're going to see, if Kibana times out, it's because it's trying to deal with too much data. Like
Can you
Elastic.
just zoom in just a little bit on the browser.
Yeah, what's the
Control
hotkey?
plus a couple times.
Where's my plus key? Oh, I don't have a keypad.
There you go. That's great.
Okay, cool. So just so I'm not lying to you, let's go ahead and pick a date range here. Absolute date. Has anybody got a favorite day?
October 13th.
October 13th. Can we start at midnight? Is that cool with you? Okay. So then we're going, what, October? Well, let's do November 13th, and we'll take a look at the whole month just to see what kind of time slice we have here. Okay, so, all right, we just returned 1 million hits to the UI, about that fast. Oh, November 13th, we can't. Yeah, my data set ended at October. That's less exciting. Okay, so we're just on the Discover tab poking around, and you can see the JSON that we passed in here. This is what our schema looks like. We have how long the trip took, I'm assuming in seconds, but we have a start time, the start station ID, which is going to be, a physical bike kiosk. The name of the station. There's a latitude, longitude, finish. Then we have some information about the actual bike itself, the bike ID, what type, a subscriber or a customer, birth year, when that user was born, what their gender is. Okay, so we'll start with that. And that's what our data set's going to look like. I actually have a script to do this. So I'm going to go back to my script here, George. Sorry. So you lose your date. September 1st. And I'll put in October 1st here. Let's see. Should get about 2.5 million hits. Perfect.
So
Okay.
these hits were queries to search, or these
Yeah.
were how the data was loaded?
No, these are queries to search. Like this is actually interacting with Elasticsearch as we're doing it. So we can do quite a few things. Like if you want to see, Max was talking about the query. If you use one of my favorite features of Kibana, if you're using this, you don't have to use this UI. But if you want to build your own UI and use the queries that you're using in here, you can hit the inspect tab up here, and you can actually see what Kibana is passing to the database in terms of a query and what Elasticsearch sent back. Maybe if the UI, oh, I clicked response and there's 2.5 million records. That's gonna get ugly. So let's see if we can, nope, I think we just locked up the browser.
So are you saying you made 2 million? So in your test, you would just do queries, or is this something you're actively doing?
No, this is something I'm actively doing.
Okay. So you're this is
and it's
less active now.
Yeah, it's trying to push 2.5 million records to my.
no. But I mean, you got all these queries.
He's
You've been
trying to
using
render
this data for a while, basically.
Say that again. Sorry.
With your 2 million queries over the month, you've been running against this data for a while, basically.
Well, I've ingested past data from the Citibank bike program thing. It's a data set that I basically grabbed every file from October 2013 to October 2019. So it's got 6 years of bike usage data.
Yeah, no. I'm just trying to figure out the hits. So that's like queries that you've done, or that's a lot of data.
No, this is the number of records.
Records. Okay.
Yeah.
That's okay.
Is it doing any sort of caching optimization at all on top of Elasticsearch, where it knows that you did a query in a date range or something and it uses that to return?
Yeah, I'm not quite sure how it works, but I know subsequent queries get faster. So, all right, so I'm going to create something quick here. Let's do just a vertical bar chart, which is what we've been looking at. Tell them, I'm going to say, okay, make sure that this matches up with my number of hits here, my 2.5 million. So I'm going to split this bucket by adding an x-axis. Let's go by histogram, field, oh, not date histogram, regular histogram. Thank you. We're going to do bike ID minimum of 1. Let's see what that comes back with. Okay, so here's all the bike IDs over that date range that we were looking at earlier. And that's not so useful to grab, a specific bike ID. So this looks like a particularly heavy usage. So I'm just going to drag that and watch it automatically add some filters for me. That's not very useful either. Let's keep dragging in here. 3.9. Okay, we're still not into individual bikes yet. See, and as I'm doing this, it's adding filters and it's rerunning the query against those filters. But you can see how responsive this actually is, especially when we get to like $39.99. That's 284 records just right there. And it searched the entire database for it while we were just live dragging. Like that's pretty cool, honestly.
Is that the real time that you were referencing? Is that the feature when you say real time? Is that
No, so
When I say things like real-time analytics, what I mean is Elasticsearch is what Walmart uses for their point-of-sale recording. So Walmart can tell you how many bananas were sold at 2:30 p.m. in any given store in the country on a Tuesday afternoon between 2:15 and 2:30, right? Like, and it handles that amount of volume. So after a banana is sold, this database will get the information from that POS system somewhere between 10 and 15 seconds later. So they know what's going on in every store, every geography, every breakdown that they want across all of their point of sale systems. And that's a really powerful tool. Okay, so we have 3.9. I'm gonna delete that, and we'll go back to just specifically requesting a filter. I'm gonna do bike ID is 39339. Okay. 421. Okay. Now what I'd like to do is we will switch this. Instead of doing bike ID, because we've got this filtered, just out of curiosity, what are the birth years of the people that rode the bike in that month? Oh, well, that looks weird, doesn't it? Yeah, there's an awful lot of 1969 in there. Like a disproportionate amount of 1969.
We'll probably have an outlier.
Yeah.
Right?
Yeah, well,
when
let's.
people put in when they ask for birth year.
Well, or there's an application default, right? Like,
Yeah.
okay, so.
I've seen one of the data sets.
Yeah.
Like put 69.
It's a nice number.
I've seen
Yeah,
it with other things.
That is absolutely correct.
Like this.
So let's split series here, right?
1970. It could be about US.
What? Yeah, that's certainly possible. What if we did a term aggregation?
This was 40 years ago. I could see 40 as a default.
Yeah, absolutely. It's more than likely a default.
Someone would just start in 1970, someone last day in 1960.
50. Sorry. I can math.
Well, what if we split series by user type? Okay, so now we've got subscribers on one hand, people who sign up for the service and they have like a monthly or a yearly pass, and then one-time customers. Well, yeah, that looks a little odd, doesn't it? Most of our outliers, one-time customers, who may have just gone to a kiosk or gone to a phone and been like, oh, I need a quick bike ride. I'm going to leave the defaults. Just sign up. Give me a bike right now. So yeah, that certainly looks like an option there. So we've identified an outlier already, and that's just by poking around at the data and not really knowing where we're going or what we're looking for. There's an outlier.
Is there like a user account field or something? Does it indicate like people who have registered with a user account versus people who are getting it as like a guest account?
Yeah, that's what subscriber versus customer is. So the customer is the guest account.
Yeah.
And you can see the guests are really messing with our numbers here. But what are we going to do about it?
Would you be able to just compare another month? Does it see that?
Yeah, we can
change
pick it.
over several months?
What months do you want to
Just
pick?
go back 1 month or something.
July.
Is that outlier still the same?
Wait a minute. We could just go an entire year. Let's talk about all of 2018, or 2018 to 2019.
For the same bike, right?
Oh yeah, for the same bike. Good point. What if here's where I break the UI. Is it going to time out?
So you mentioned that you ingested
Nope.
this data already and then allows you to just run these queries as you like.
As I'm poking through it, yeah.
Okay.
So for that year, we just ran through how many total hits? Whatever the derivative of that curve there is. But yeah, if we want to filter this out, right, we can take we can take that particular user type out of it, right? So let's do user type is not, what is it, customer? How long is it going to take to run these 10, 15 million rows? I mean, keep in mind, this is a lot of rows against a...
So all your menu choices are built from the schema that you used to populate.
Yeah, the
to
mapping
create
file.
Right.
The
So there's a couple.
the-
There's a couple things at play here. So there's the query. There's the query DSL that Elastic has that lets you do the aggregations and split up these buckets and do the operations on the data. And then there's the data schema itself. So there's a combination of the UI saying, well, here's what I can do query-wise in Elastic, and here's what your data looks like.
Yeah, and you can, if you're a fan of the Inspect tab, you can download the CSV here, right? Like you can see any of the...
There's some really powerful people who were born in 1874 and they're still alive.
Yeah. You gotta wonder how many people
think that's
put
an
junk
outlier,
in there. So you can, again, you can see the request queries that go along with Kibana. So even if you were just tinkering around with Kibana to put on some other UI later, but maybe you're using D3.js or something and you want to just use this information, you can copy this request ID and then, you know, come up with, paste it into the request that you're making from D3 or whatever your client app is and use the same data that Kibana is accessing. All right, so yeah, I have a pre-made, well, I could create a pie chart for you guys and you guys would believe me, but in order to save time, I'm going to skip ahead here. So we can do things like pie charts. Go figure. Guess what? 1969 is our top contender for birth year again. Okay. Another thing I want to do, or another thing that I'm going to go back to is our bike trips by our trip count. And I was going to make all these in real time for you, but in the interest of not, you know, boring you to death during this process, I'll skip ahead to where I have them built already. But this is a list of count of the number of trips basically by week right now, and if we zoomed in a little bit, it would go down to day, I think. Yeah. So we can get this, and we can always go back and filter by our favorite bike ID, which I believe was 39339, I think. Nope.
Yeah, there was a 3 at the end.
It was a what?
I think there was a 3 at the end too.
No, I don't think I have that. Oh, you know what? It probably wasn't active during this time period, that specific bike ID. So let's jump back to, yeah, see, it just wasn't active then. So what you can do is you can basically create a whole bunch of these visualizations, and they all share date ranges, and they all share the filters up at the top corner. And one of the really cool parts about Kibana, oh, this is the wrong app. I just loaded Canvas. I should have hit that one. This works. Okay.
Because it's not trying to render 2.5 million.
Download, yeah. So the map API is really cool. And what I've done here is I've taken a map of, you know, New York, because that's where the city bike thing is. And for any given day, we can use this, we can add a map layer that has the sum of the trip duration is our metric for any individual point, right? and then it'll allow you to add layers with a color and a certain basically pen width. So you can get a pretty accurate map of where the bike's been over the course of one of those days. And then what's really cool about Kibana is it lets you tie this whole thing into a dashboard that you can save. And you can save all these charts together, and it's basically a drag and drop interface, which I'm not going to put you through right now because, again, we're running a little behind. But if I was to, basically I plop the map on here. Oh, that's all month. Whoops. So I designed the map in the map designer that I showed you before, saved it. I took the 2 charts that I had before, saved those, and I created a new dashboard, and I dragged the map on, and I dragged those charts on over on the side. And what it gives us the ability to do is, actually, let me set this back to 100%. So what it gives us the ability to do is actually project interconnected sets of data. So if I click on one of these here, notice the birth year and the map is updating in real time as we drill through these filters, right? So I think now we're on July 9th, noon till 3 p.m. basically. So where was this bike noon till 3 p.m.? And we're following it around Manhattan on July 2019. Yeah. Start point, end point, sorry. I don't have interestingly enough, I've done this with some Internet of Things devices that will record like real-time GPS, and if you plot it as dots instead of lines on the real-time GPS, like you can actually see like the dot path as it moves like around corners and stuff. This particular one was on a tractor in a farmer's field, but like you could see the farmer go down a row and then turn and come back, and it was pretty boring after the first 12 seconds, but like for that 12 seconds you're like, wow, this is really neat. So that's basically how you build a dashboard. Well, let's do something ugly here. I'm gonna nuke the filter for 39339. Yep, there we go. There's some bikes. So it over the course of 3 hours this day, well, let's filter down. Over the course of 5 minutes, this is all our bike paths for the bikes in New York City at the city bike rental thing. Like, and that's how a lot of companies are starting to do, real-time analytics, is because with a lag of, 15 to 30 seconds on your ingest pipeline, you can get this type of information, this type of dashboarding. And the really cool part is, like, if you don't want to expose all of Kibana, you can use this share link thing up here, and you can get embed codes for your websites, and they'll actually pull the JavaScript artifacts from the Elastic company itself. And as long as that Kibana instance can hit your Elastic server, it'll expose that data to that client without them being able to tinker with the rest of Kibana. So it's a pretty neat tool, and there's a lot you can do with it, and it's super fast.
With that data updating real time, as Kibana's ingesting more data, is it possible to have it run like a real-time device?
Yeah, so where's the auto? There's an auto refresh setting, and I lost it in the new version of Elastic because it used to be right here next to the thing. Refresh every X number of seconds. So you can do like a running dashboard.
Exactly.
And that's actually what, so Zach works with me. That's what we do at one of our offices, is we have like we basically have a DevOps dashboard. It gives us like an list of errors, where they're coming from by application name, which servers are starting to go nuts, and we have that refresh every 30 seconds, and it has data from the last 30 minutes. And so that's actually, DevOps is one of the major reasons that people are using this. But I kind of wanted to come in and say, you don't have to use it for DevOps. You can use it for whatever data series you want.
Yeah, you use it like delayed flights or number
Yeah.
of people that are standing in queue.
Yeah, and this is just scratching the surface of the visualizations. It's like they have a whole time series thing that I've disabled here. And one of the coolest demos I've ever seen was at Elastic on 2017. They had this interpretive dancer, and they had sensors on her hands and on her chest, like for heartbeat monitor, and on her waist and her legs. And they had a Kibana dashboard up on a screen behind her, and as she was moving, this Kibana dashboard was tracing in real time, like where her hands and heartbeat and everything were, and it was like streaming behind her. It was really neat, really well done. So there's all sorts of stuff you can do with this. But yeah, I just I wanted to give you sort of a rough idea of what the capabilities were. You're definitely on a quad-core machine with 16 gigs of RAM, and not terribly too much I/O. It's doing a pretty good job, and if you loaded that into MS Excel to try to use Power BI, I'm pretty sure you'd have an issue. So anyway, I'd like to thank Max again. If you guys have any questions, feel free to just pound on us for 10 minutes or so.
Yeah.
while
We got plenty of time, I think.
So if your scheme that you first start with, say you want to index something else, will it just, when you update your scheme, do you actually update the existing scheme, or do you just make a new schema that adds the one field, or it just generates
You
the
can go
table?
both ways.
What's that?
You can go both ways. So a really popular way to do this sort of streaming data is to use what's called an index template. And what you might do is set up the template to have a certain number of fields in it, and then over some period of time, like maybe every day, you have a new index and you kind of alias them, or in SQL terms, union them together to get your data sets. That doesn't work terribly. That actually works like really well. And so what'll happen is, if you want to introduce a new field, you add it to your template, and all the new indexes going forward will support that. But being a JSON-based document database store, you also can just start throwing new attributes at it, and it'll just pick them up.
And so with text, it's a bit different. So it's really easy to add fields. You can add fields. Your old documents that you've already indexed aren't just going to automatically manifest that data in the index.
Okay, so
You'd have to send the documents back in.
Okay.
It's called a reindex.
Right.
If you change any of the settings and stuff that I talked about before, the filters, the analyzer, things like that, if you change a field, you have to reindex it, because you're changing the way that the term gets normalized and then stored in the index. So you have to basically start over. You have to change it and then start over. And that's actually a big problem that people run into. So the typical strategy is, and Elastic has a really nice API for this called the reindex API, is you'll have your index or cluster that's running of V1, right? You want to update something, you want to change a field or add some fields or change some stuff. You set up a cluster V2, and you stream the docs into the new version with the new schema, and you do that simultaneously, so you're still live here.
Right.
And then as soon as it's done, you eventually get to a sync point, and you just cut over, right? So that's a typical strategy that you'd have to.
Because the index must take a while.
It can. And it depends on the size of the corpus, but I'm a consultant now, so I work with a lot of different companies. But my last job at Wolters Kluwer, I was responsible for a search service that had a lot of content in it, and a reindex operation would take 2 days. So 48 hours, and that was like not huge. And that was an Elastic that was Solr, which also wraps Lucene, and they compete with each other. That's run by a company called LucidWorks. But really, it's Lucene that does a lot of the work, and they have very opinionated ways of wrapping Lucene. And Elastic has all of this great Kibana stuff and analysis stuff on top. Sorry, that was a long answer to that question.
No, it's relevant though. Like for things that are already in the database, you don't really change them. Writes and deletes tend to be pretty expensive to Lucene. So what you'll generally do is stand up a new index and shuffle your stuff over.
More questions?
So in the DevOps case, you said a lot of companies start using this for DevOps more. Is that?
Yeah.
So they're using Kibana as well. Basically, they're setting it up.
Yeah. So they could be. There's a lot of different.
I mean, to use the dashboard at least. Right?
Yeah. Yeah. If you're talking about the straight Elastic DevOps stack, usually there's Kibana involved. Now there's a couple of, there's a bunch of companies that use Elastic, slap their own dashboards on it, and then call it a product. Like Datadog does that.
Oh, really?
Yeah, like they use Elastic under the hood. And
they
then
set it up the same way.
For a long time, Kibana wasn't the most mature product in the world. Like it's come a very, very long way in the last 2 years, and so there was a lot of benefit to selling exactly what DevOps people were looking for on top of Elastic, which is where some of those market people come from, and they do a good job, and they do a good job of selling it, and their agent is really awesome. So the value add for a company like Datadog is you put the agent on whatever server is running with the services, and it's sort of pre-configured. Whereas if you were using Elastic, you'd have to go get Logstash or beads and figure out what you want. And so there's a value proposition to that. But Elastic powers a lot of stuff, and most people don't realize the amount of stuff that Elastic's actually responsible for. Yeah. And even like so what Max is talking about in terms of document search and relevant search, Google recently stopped selling their little Google appliance thing that you stuck into the rack and pointed at all your file shares. Elastic's kind of taking over that market too. So
yeah, if you go to any application, aside from like the big tech companies like Google or Amazon or whatever, if you just go to like some e-commerce site or like like the Rochester City website or like anything, and you see a search bar, there's probably like a 95% chance that behind that search bar is Lucene. It could either be Elastic or Solr or some other thing, but that search bar is probably powered by this Lucene technology that we were talking about. It's very, very, very common. A lot of times, and that's why search is so terrible on a lot of websites you go to, because people install it and they index their stuff and they have the basics and they're like, oh, I know how to put documents in it. And then we're done with search. And then, it's live. And then people come and they search and they're like, oh, this is terrible. Like, I can't find anything.
Call Max.
So it's a problem. And it's a really, really hard problem to solve. So I don't fault people because they got a lot of other things they got to work on. Yeah. And a lot of times teams don't have the budget or the time to work on just fixing search when it's just such a small problem.
So one of the things you might do, I don't know, like going back to the Will Smith thing, where if they're searching for Will Smith, getting that, where you would introduce these filters and I can't remember what it was, the TCF stuff. That would be they don't know the product enough to put that in, and you would help them. Define their search terms and how the search should be set up.
So we help companies build stuff, but we're about like empowerment. So we try to teach teams how to manage it themselves. So that's why when I said we give a lot of training, we do strategy and consulting. We work with teams over a set amount of time, but we're not like okay, we're part of the Scrum team now, and we're just going to crank out code to build search. We try to do a lot of things like pairing. When we're not even touching the keyboard, we're showing you what to do. We do knowledge sharing and knowledge transfer. We do strategy. We're like, well, what do your customers actually want when they type something in the search bar? Answering those questions is usually pretty hard. So a lot of that stuff.
My favorite example that like when Max and I first started talking, he said, let's say you have a giant bicycle and you're going to go look for tires, and you go and you type in giant tires.
Yeah, giant bicycle tires. Do you
Giant
want huge
bicycle-
tires?
Do you want
Or do you want
huge
tires for a
tires?
giant bicycle?
Yeah. I was like,
Yeah.
okay, you got me, you win. I absolutely.
Oh, there's billions of
Oh yeah,
of examples.
yeah, that was a good one. I just like think of a guy riding like a little bicycle frame on a monster truck tires. Yeah, that's a good example.
I had a question, I had two questions. The first one for Will Smith piece. Now, in terms of searching, when you put in the Will Smith initially, it came up with Mr. Smith Goes to Washington. The technique that comes to my mind is if I'm searching in any general search box, I can put an apostrophe or in parentheses or in something to. It has to come in this order. Will Smith. Is there some, what would be the method, I guess, in this particular approach?
Yeah, that's a great question.
To
So,
achieve that, right?
so there's like this. So there's the query DSL, and then there's like the internal, like what can I do as a person? So that query DSL that we were showing was, you wouldn't expose that to your customers, right? You wouldn't say, well, type your JSON query. You'd say, well, here's your, give me your text. So typically that is managed ahead of time, just as you would sanitize like a database input, right, or something like that. Somebody's typing something in a text field, you sanitize it. You look at it, you make sure it's okay. There's no injection or whatever, and then you have a SQL query, and you eventually that becomes part of the SQL query that you pass in. So you have this behind, abstracted. So you do the same thing. So you can just provide the language that comes out of the box. So you like have quotes, Boolean and or stuff like that. A lot of teams, they put their own query language together as a service, and then say, well, we'll support some basic stuff, and we'll parse it and analyze it, and then we'll construct the larger Elastic query and send that in and get the results back and send you the results. So there's typically a lot of stuff happening in the middle here. The common thing is like, quotes, right? So I'm going to search, well, I don't want Mr. Smith Goes to Washington, I want Will Smith, so I'm going to just put quotes around it. That's one most people know. Most people also know Booleans. Some of the things that people don't know are like, you can put the field name : but you don't know what the schema is. So you can say, well, title : ... Most people don't know what the name, it could be title, it could be title _ text, it could be blah, 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 you have no idea. So there's a lot going on there, but we spend a lot of time with that as well.
For that sort of thing, sometimes it helps to have like a semantic layer, right? Like
Yeah.
where you'd have a mapping between what stuff is called and what it's actually called.
And my second question is related to the visualization, the mapping specifically. That's sort of out of the box in terms of what you just displayed there.
Yeah, everything that we showed you tonight was available in the Elasticsearch basic free version, except for the machine learning that I talked about a little earlier. Like, now that you see how to do the analytics piece, what the machine learning does is it sort of looks for patterns on any given set of metrics, and then it'll build cycles for those metrics. So if something happens on a daily or weekly cycle, and then if those metrics go way out of bounds one time, it'll flag it and message you. And there's some other stuff that's in the enterprise version, but
Is Kibana all under the Elastic license, or is that any of it Apache 2?
so there are Apache 2 versions of both Elastic and Kibana.
Well,
The
Elasticsearch,
maps-
I know, it gets cut up in different ways depending on what
Yeah,
features you
the
use.
license is confusing, but basically the maps, the basic maps, which isn't the one I showed you, the basic maps is covered under the open source license. The actual Elastic maps are under the Elastic Basic license.
So there's kind of a couple of different, like with the basic maps, you can do heat maps, you can do area aggregates and stuff like that, but you're not going to get like the individual point-to-point tracing like we did here, if that makes sense.
More questions?
So I was going to like give a sticker to whoever could do the most popular bike station by like a histogram of the most popular bike stations by on their birthday or whatever, but we have so many stickers, I think that exercise is out.
Please take stickers.
Yeah, please take stickers. We have
Please
many
take
stickers.
stickers.
Slap them all over your laptops. If you have any questions about what the products are, you can, elastic.co is the website, or I generally know some of the stuff.
Is everybody on the RocDev Slack?
Yeah.
Yeah.
You can ask us questions. I'm there all the time,
Yeah.
talking about nonsense, but you
Yeah.
can talk about serious stuff if you want.
It's RocDev Slack's a great resource for when my cloud formation's taking a while. So just
You had a question? Yeah?
Yeah, I just had a quick question. Let's say you wanted to set up Kibana, but pointed it to a couple of different data sets for different reasons. You want to use Kibana, but in a couple of different ways.
yes.
Would you need multiple instances of Kibana?
No. So under Kibana, there's these things called index patterns, where you actually tell it which data sets you're going to use within your Kibana instance. The one that I have is bike trips, and you can see what the data points here look like, right? But the other one is TMDB. So technically we could go build a visualization on the most popular actors over the last 5 years or whatever, and that still would be an acceptable data set to do that. And you won't be able to build a dashboard. You know how, like on your dashboard, or on the dashboard I showed you, you could click into a date or a
Yeah.
specific thing and it would update the filters. You won't be able to build a dashboard across index patterns, but you can build 2 different dashboards with 2 different index patterns.
So this is just one instance of Kibana hosted on like a Linux box or something?
Yeah, it's a Linux VM in my basement.
And Elasticsearch and Kibana are different services. So you create as many indexes as you want in the Elasticsearch service. And then Kibana, you create index patterns around those indices. And then you visualize based on an index pattern. So trying to figure out the relationship.
Well,
You can create as many indices as you want on the same Elastic service with that simple REST API call that I said. You just need a schema and some data.
if you really want to blow your mind, you can set which index Kibana uses, and you can run multiple Kibanas. On
Oh,
the
that's
same
right. Yeah,
Elastic.
Kibana persists
Yeah.
its own state as an
Right.
Elasticsearch index.
Right. So it uses Elastic as its database to store its stuff, and you can tell it to use different Elastic indexes, so you can have multi-tenant Kibana on the same Elastic cluster.
It's like Kibana Inception, I think.
Yeah, it really is. Yeah, but Kibana is pretty lightweight. Like, it's just a Node.js app, and you can run it on 512 meg.
One
VM.
pointer, because I ran into this. If you're installing Kibana and you have a virus scanner that scans every single file,
Oh my gosh.
Kibana has like a bajillion tiny little JavaScript
It
files.
does.
Turn off your file by file virus scanner when you are installing Kibana.
Yeah.
Otherwise, it will take like a day.
Or
It's a
installing
Node
your
app,
VM
so.
and just-
Yeah, it's Node, so that's what probably like 20 copies of left pad in there.
Yeah.
That never gets old.
Never, never. Any other questions?
When you make new index patterns, does it force a reindex?
No. An index pattern is just looking at the indices that are already created.
Yes.
So if you can create more indices or you can create more index patterns, would it be cool of you to set up just as many indexes as you possibly can in the beginning so you never have to reindex, and then just do index patterns to manage it?
So you remember how I was telling you about the union thing that Elastic calls aliases? Basically, it treats the indexes. It treats each index in an alias as a separate shard. So what'll happen is you can build an index pattern against an alias where the alias has multiple indexes underneath it, and whatever index properties those, or whatever fields those indexes have in common will show up in the alias. So you can just keep adding indexes to the alias, and then Kibana will kind of
Well, that'll
figure
save
it out.
your work to make index patterns. Or
Yeah.
Not the other way around. It won't save you from having to do a re-index when you want to have new index.
No, but if you're re-indexing for new data, you won't have to, because you can just stand up an index and add it to the alias. If you're re-indexing old data, you still probably want it covered under an alias, because you can drain one index as you build the other one, and Kibana won't change. I know that was kind of more Kibana inception, but
Yeah, it's just another, I'm just pointing out the pain point. You basically want to try and make sure your data is, you have as many indexes as you're going to ever want in the beginning, so you can prevent the need to re-index too often in the future.
I don't know that it's that bad. So the reason I bring up the alias thing is generally, the way I've built it into my software is most of my software references an alias instead of an index directly. And so when you reference an alias, you can really futz with the indexes under the hood, and the alias behaves really well.
Yeah, well, like the example that I'm playing with in my head is logs, right?
Yeah.
I've got, a dozen teams, they're all working on a dozen applications, let's say.
Okay.
And each team has the right, every time they make a new application, to change what things they might put in their logs. Right?
Okay.
So now you have a different thing you might want to index on, or you might want to do query patterns against,
Mm-hmm.
which you don't want to historically, every time a team spins up a new project, to have to re-index your entire log history. Right?
But you don't, right? Okay. So that's kind of where I was going with the templates in the alias, is because if you create a new log pattern every day, right, and you just alias them together, and then you kind of let the older ones fall out, because let's face it, if it's 2019, you're not super interested in the logs from 2012.
Sure.
So as you need more stuff, add it to the template. It'll get created with the new indexes every day that you're generating or whatever. And your indexes will shift over time. And your index pattern, you just remake your index pattern based on the alias or the template that you have for that day. And then every day, whether you have a new set of completely new set of data fields or not, you're still getting the freshest set of whatever you have, right? So let's say, your release can probably wait till tomorrow, or at least you'll see it coming in QA or something. So add the new fields in development, and by the time you're ready to release, you already have your template updated and you're ready to go. And since every index is a separate day, naturally the newer ones are going to have the complete information, and the older ones you'll still be able to get useful information even though you don't have the fields, and you won't have to re-index that at all. So yeah, but at least that's kind of how I deal with it.
Yeah. It's just one thing that's like, you have something like Splunk or something like that, sure, it's painfully slow when you run a query because it's real-time calculating that out all the time, kind of in a linear search fashion.
Splunk uses Elasticsearch.
Does it use it?
Yeah.
Does it
It's
use
just
it now?
Oh, what's that?
Does Splunk use Elastic now? Because it's been proprietary. I thought they were a main competitor.
Last I knew they did.
That's
Do you think they diverged? Because I'm pretty sure the engine itself, it's like Datadog, right? Like I'm pretty sure the engine itself.
Splunk's been around for a while. I think
Yeah.
Splunk was pre-Elastic.
Yeah, but I think they're using it now.
Have they now started using it? Interesting.
Last I knew, Splunk
Okay.
used Elastic, and it was another one of those cases where we're going to take care of all the ingest and we're going to take care of all the dashboards and we're just going to.
Well,
I
going
mean,
to
I
my
could be
example,
wrong.
Because like going to my example, I've done that before in Splunk, and you can run the queries against it, but the queries are always painfully slow with how much data we pump in anyway. So we do like 300 gig a day in
Yeah.
logs. So getting up to petabytes is not how we measure things in our logging system. But the queries are really, really slow, like really slow.
Elastic was talking about exabytes at their conference last month, so you might be talking a couple thousand servers or instances or whatever.
Yeah, that's
but
it's not like magic. You can't just host all that stuff on one server with Elastic. You still have to spend a lot of money on infrastructure.
Man, I thought I was doing good with my 85 million. But yeah, it's going to be a question of, however much parallelism you can throw at it.
Sure. Yeah, well, we pay a good amount for it. I'm just trying to find ways that we can maybe not pay as much or maybe not pay as much in time.
I mean, and the other thing is, like, if you're 300 gigs a day, you start with a simple 3-node cluster and just do one day and see what it looks like.
And so we should point out, so Elastic has a cloud called the Elastic Cloud where you can buy and just pump your data there. It's competitive to Amazon, which also has their version of Elastic, and you can point Kibana at the Amazon Elastic Open Distro and the Elasticsearch service in Amazon. That can get really expensive if you don't know what you're doing, because I think that it doesn't really work in the way that you would think of, like, I have one instance and then I'm going to pay to add more. I think it just kind of like takes the data and then you get a bill. So set something up on your own first, test the performance, understand what the thresholds are, what your budget is, how much data you can go. I know people like to say, well, I'm just going to index the world and then see what I can do with it later. That might be fun, but it might be really, really costly and slow. So find the balance first before you commit to going that route, and understand your comfort level and what your throughput is on your data.
Yeah. I'm a big fan of, like, if you're standing up AWS instances, the i3.extra large has a really good balance of CPU, memory, and NVMe based storage that'll get you that pretty much hits the sweet spot for me. Like, if I'm gonna spin those up and install Elastic myself, like in a VPC or whatever, those are kind of the sweet spot of price to performance. And then you can just, like, start with 3 of them, and then when you like it, you can just make an army of them.
Yeah, I'm not sure how we host ours. So I don't know if it'll be
Yeah.
It's food for thought.
Yeah. Well, I mean, if you have questions about sizing and that sort of thing,
Sizing is always very challenging.
Yeah. Yeah. So there's kind of this weird.
And then you need Elastic and Kibana to monitor your Elastic and Kibana infrastructure. More Kibana inception.
Yeah.
So,
See, that's what I found Datadog to be really good at. It's like, okay, I've got Elastic and Kibana. Now I'm gonna put the Datadog agent here and let it monitor my cluster. So.
Other question?
Yeah, so related to they're referring to documents.
Yeah.
In my mind, I'm usually very familiar always hearing data. But you were very specific using documents. Why is that?
Yeah, it's a very searchy term because in full text search we think in documents. So I'm an organization and I'm selling clothes, right? It is data, but I think of, like, one item of clothing as a document that has a description, a title, a manufacturer, a size, like lots of different metadata. So we call that, like, thing a document in the search world that you can search on. You can search the text, you can search the metadata, you can filter on the metadata to see, well, I want black T-shirts. So I found T-shirts. Now give me all the black ones and give me all the large ones, right? To do the filtering operation. So that's the unit that we think of in the search world is a document. I don't know the origin of that, but I think it has something to do with text, full
I
text.
feel like it's JSON document, right? Like that's kind
JSON, I think, is also called a document.
Yeah, so
it's like
that's
one
kinda
thing:
how I
XML,
map
HTML, JSON. It's like
JSON document to index record.
Yeah, a record is another way
Yeah.
to refer to it as. I think that's more the relational database-y way to say a record.
Oh, more shameless plugs. Elastic has a lot of connectors. So Spark, Hadoop. At one point I went through, like, I took data in an Elastic cluster, wedged it through a Spark connector, or a Hadoop Spark connector, and then put it into, like, H2O.ai just to...
Oh, yeah.
Yeah, like, you can... Kinesis, Kafka, like, just connectors all over the place for Elastic. So once you have your stuff in, you can do lots with it. Okay, hit me with more questions. I know you guys don't want to fall asleep yet. Is that it?
Yeah. Before we close, I want to thank you, George.
Yeah.
Because you're the man behind the camera, and you did a lot of organization.